In our previous video we have discussed SAM and FAP rule, and in today's video we will discuss some examples and calculations to understand how this rule applies in clinical situations. So example number 1, we have a contact lens with base curve 7.8 millimeter and we have changed its base curve to 7.7 millimeter. Now we want to know how this change in base curve affects the power of contact lens. So the question in your mind should be, is the new base curve steeper or flatter? So you must remember that lesser the value in millimeters, steeper is the base curve of the lens, and greater the value in millimeter, flatter will be the base curve of contact lens. If you remember this rule, you can solve these questions very easily. So in this case, here you can see that we have decreased the base curve of the contact lens. So decrease in value of base curve in millimeter indicates that the base curve will be steeper. So that means that the new base curve is steeper, and for steeper we apply SAM, steeper add minus. So we will add minus power to the power of contact lens. And how much minus? Here you can see the difference. The difference is 0.1 millimeter, and 0.1 millimeter is equivalent to 0.50 diopters. So if the power of contact lens is, for instance, minus 4, we will add minus 0.50 in it, and the net power will become minus 4.50. So in this case we have decreased the base curve, made it a steeper, and therefore increased the power of contact lens. Now example 2, original base curve is 8 millimeter, the new base curve is 8.1 millimeter. Now in millimeter we have increased the value, that means that lens is flatter. So we will apply FAP, and according to FAP we will add plus power. How much? Again here the difference is 0.1 millimeter, so we will add plus 0.50 value in the contact lens power. If we take the same power of the contact lens as we took in previous example, that is minus 4, so when we will add plus 0.5, it will become minus 3.50. So in this case you will observe that the power of contact lens is decreased. So by increasing the base curve, the power of the contact lens decreases. Coming to example number 3, here we have base curve in diopters. Original base curve is 43.00 diopter, and the new base curve we have taken is 43.50. So you must remember, greater the value in diopters, steeper will be the lens. Lesser the value in diopters, flatter will be the lens. So in this case we have increased the value in diopters. So that means we have moved towards steeper side. So we will apply SAM rule, and we will add minus. How much minus? Difference between new base curve and original base curve, which in this case will be 0.50. So we will add minus 0.50 into the power of contact lens. If it is plus 3, then it will become, after adding minus 0.50, it will become plus 2.50. Coming to example number 4, here we have base curve 43 diopters, and the new base curve is 42.50 diopter. So we have decreased the value of base curve in diopters, which means that we have made the lens flatter. So in this case we will add plus 0.50. Why? Because the difference between both original and new base curve is plus 0.50 diopters. Coming to example number 5, original base curve, now again values are in millimeters, 7.80 millimeter, and we have taken a new base curve with 7.9 millimeter. So the difference is 0.1 millimeter. So again the change will be 0.5 diopters. In this case, we have increased the value of base curve in millimeter. That means that lens is flatter. So for flatter, we will add plus, how much plus? Plus 0.50 to decide the final power of contact lens. Coming to example number 6. Here original base curve is 7.8 and the new base curve is 7.6. So the change is 0.2 millimeters. 0.2 millimeter is equal to 1 diopter. And again we have decreased the value. That means that lens has become more steeper. So for steeper we have SAM, we will add minus, how much minus? Minus 1 diopter. So the if original value of contact lens is minus 5, after adding minus 1 it will become minus 6 diopters. Coming to example number 7. Original base curve is 44 and the new base curve is 45. Again the value in diopter is increased. That means the lens is steeper. So how much value we have to add? That is the difference between 2. 45 minus 44, that will be 1 diopter. So we will add minus 1 diopter. So if contact lens power is plus 5, so adding minus 1 will give you plus 4. Coming to example number 8, here we have original base curve 44 and the new base curve 43. So value in diopter is decreased. So this is again flatter fit, and 1 diopter we will add according to FAP rule. So here we have an example. This is for your exam questions, and these questions are very important from exam point of view. So we have a GP lens that has original base curve 7.8 millimeter. The new lens has base curve 7.7 millimeter. So what power change is required? You have to calculate the power change. First you will see the difference between these two readings, that is 0.1 millimeter, and 0.1 millimeter is equivalent to 0.50 diopter. Next you will see is the direction of base curve change. In this example, the base curve is decreased. That means the lens has become steeper. So we will add minus 0.50. Coming to example number 10, original base curve is 43 diopter, new base curve is 42 diopter. So what power change is required? Simple, you will take the difference between the two. That will be 1 diopter, and since we are moving towards the flatter side, so we will add plus 1 diopter into the final contact lens power. One more challenge for you. A GP lens has original base curve 8 mm, the new base curve is 7.8 mm. So ask yourself, is the lens fit is steeper or flatter? Do we apply SAM rule or FAP rule, and what will be the approximate power change? Solve this question and tell me in chat box your answers that I will evaluate later on, and some more examples for you to solve. Do solve these examples and write your answers in the comments.